right, so this feels like a bit of a small room for me to start shouting, "This is something." So just welcome to Computer Science 164. This is meant to be a continuation of sorts of CS50 for those of you who joined us this past fall or in years prior. Indeed, if you don't recall, here is where we last left off.
Good work.
So now begins part two. So this is meant to be ultimately a class on software engineering in a mobile context. And what does that mean? It means building upon the sorts of things we looked at and learned in CS50, but really taking your abilities and your knowledge of programming and engineering more generally to the next level. And certainly today, almost everyone in this room probably has a mobile device, and this is a new domain in which all sorts of fun, new, interesting problems arrive, among which are the size of these devices, the amount of memory in these devices, the CPU constraints, the network constraints. And so there's all of these computer science challenges that we're now revisiting in this more limited environment. So it's an exciting time both to do web development in this space as well as what we'll call native development. But more on that in just a little bit. So what are the differences between this class and perhaps the one you took prior or a few years back? So ultimately in this course, it's meant to be collaborative between you and a partner. Indeed, as the syllabus says and as the course catalog says, you'll hopefully have entered today or will exit today on the lookout for a partner with whom to take this course. There's relatively few courses at the college in which you really do work hands-on throughout the semester, and it's really key that you find someone with whom you work well. Case in point, I took a class called CS164 when I was an undergrad years ago, and I had one of my good buddies took this class with me, and we had perfect chemistry in terms of personality. We had perfect work habits in terms of who was up when and how we communicated. And so what you really want to be on the lookout for as you think about whether or not to take this course and with whom to take this course, who would you work well with? If you don't have a friend necessarily with whom you could work or that you know is taking the class, we will help. But do enter this course with this mindset, because ultimately the course is about engineering larger pieces of software than you did in 50. And whereas 50 was largely you autonomously, now the projects will be spec'd in such a way that you just can't or won't want to do each of these projects on your own. And so among the challenges are going to be figuring out how you divvy up the work, how you intercommunicate, and ultimately how you build something more interesting together than you might alone by yourself. So what are the tools and languages that we'll be using in this class? So as the course catalog alludes to, we'll be using a palette of languages, not so much because each of these individual languages are the languages you must or should know, but rather they're going to allow us to explore a lot of the ideas that ultimately underlie the course, those involving design of software and construction of much larger pieces of software. So why these languages in particular? Well, certainly the web doesn't seem to be going anywhere, but we'll look at some of the newer and fancier features of HTML, labeled HTML5. And this isn't just new tags. This is new capabilities that the latest browsers actually have inside of them, including geolocation, the ability to ask the browser programmatically, where is this user geographically, the ability to store data in the user's browser beyond the scope of small, simple cookies, and all sorts of other new features, among them graphics and the like. PHP, because most of you are entering this course presumably with a background in PHP, and even though this language has grown up fairly organically over the years, it's now maturing into a language that has a lot of the features that we would like to talk about in this class and that you'll find in other languages still. But undoubtedly, could you explore the same concepts in a class on Ruby or Python or whatever your preferred language happens to be. But we'll also use JavaScript, which has really come into its own. Years ago, being this annoying little language that did little more than trigger pop-ups and redirect you to other pages, now it is the way by which you can make the most dynamic and interesting of sites. And then finally, Objective-C, which syntactically will probably bend your mind a little bit, but ultimately it's a superset of C, the language that you all learned presumably in CS50. And what's nice about this is that, much like PHP and JavaScript, it'll allow us to continue the conversation from fall 2011 or prior, so that the ideas are new, but a lot of the syntax and a lot of the language details are actually a very natural next step. So with that said, how is the course going to work in terms of workload? probably going to be as much or more than CS50, but spread out over more time. As we'll discuss in just a little bit, not only will you be working with a partner, we're also going to have 4 release cycles, whereby over the course of 4 weeks, will you have a number of milestones that you need to hit. So what I think you'll find is that unlike 50, where you pretty much have this constant something to do every week, you're going to have a little more wiggle room over the course of the semester, which isn't to say you can just still postpone it till the very last minute, because now you have to coordinate with another human being who has constraints on his or her time, so you're going to have to navigate those waters as well. But more on the particulars of projects in just a bit. So ultimately, this class is about design. And so now I have this opportunity to pick on that class called CS50, in which we don't necessarily do everything in the best way, partly because we're strapped by the tools that we have. So case in point, you might recall this snippet of code that we introduced roughly halfway through CS50. And this was in the context of what data structure? Yeah, so this was a linked list. And if you recall, this was our very first example of linked lists. This was the code version of when we had the humans come on stage and point at one another with holding numbers. But this was not, even in version 1, the best design. So a struct is just this container in which you can put multiple variables of various types. But pick on this design for a moment. What is bad, perhaps, about this representation of that thing we called node, if the goal is to create a linked list? Find fault in this design. Yeah?
If you start from the beginning all the way to the end, whenever you're looking, you can't move.
OK, good. So fundamental to linked lists is their singly linked nature, whereby, yes, you only have to remember one pointer to get from first to last element, but that's also the same problem. You have to start at first and move to last element. So we talked about big O of n time to search this data structure. Of course, the upside is that we have some dynamism. But here, too, there's also more of an underlying concern I have with the specific implementation. Perfect. Yeah, so besides that, besides the sort of fundamental theoretical constraints on the data structure, I've also literally hard-coded in int n. Now, the variable's name is inconsequential, but the data type is rather consequential. So if I wrote a program that had linked lists, and I then wanted to use my same exact code for maybe a dictionary problem set, in which I want a linked list for the purpose of hash tables for representing words, what do I, or what did many of you have to go do, given this sample code? You have to change it, right? So minimally you change int to char star or to an actual array inside of the object or something to that effect. You recompile and you're on your way. But suppose the next day what you actually want to store is student objects. Well, you can do the same thing. Let me just go into my code. Let me copy paste and change. Let me change int to char or to student. And so now we have version 3. But you can imagine now if throughout the rest of your life, anytime you need a linked list, you go back to that first CS50 problem set, do a global find and replace and recompile. This isn't the best way to engineer a piece of software, right? Ideally, you just want to have a more generic container, something called linked list, inside of which you can put anything you want. And so we could take a step toward this in C. In C, even though we don't talk about it much in 50, there is the notion of a void star pointer, which is a generic pointer, which means it can point at anything, whether it's a student object, an int, a char star, or whatever. But C wasn't really designed with this notion of encapsulation in mind, this ability to store related data and related functionality together. And so out of C did languages like C++ arise, and Objective-C, the last of which we'll look at in this particular course. But notice, though, the limitations of what we did here already. Plus, then you have to go ahead and define a student. And a student we hard-coded with an ID, a name, and a house. But here, too, feels like there's an opportunity for better design, right? If I wanted to tease apart a student's first name and last name, how would you go about, in a data structure in C, representing their first and last name? So 2 different variables, right? Maybe I call it first. Maybe I call it last. Maybe you yourselves did that in your MySQL tables or the like in some final project. But there, too, it feels nicer if I could just have this entity in memory known as a student, and then I could just ask it, what's your first name? What's your last name? What's your full name? What are your initials? Right? There's so many questions, if uninteresting questions, that I could ask about this data structure, and it would be nice if to answer those questions I didn't have to manually do a whole bunch of messy string concatenation or regular expression matching or the like. I can just invoke functions related fundamentally to this object, or as we'll start to call them in the context of what's called object-oriented programming, methods. So another little example that's along the same line. So this was an earlier pset in 52, where you had to implement searching and sorting for pset 3. Well, in C, there's this very common convention whereby if you want to perform some operation on a data structure, and that data structure in this case is an array of ints, well, that's fine. You write the function and you accept as input that data structure. But here too, we're kind of destined to reinvent the wheel, because the next time I want to sort student objects or generic char stars or foo objects, I essentially have to copy and paste my sort code, change all of the data types inside of it, and then recompile or redeploy that code. So hopefully there's a better way there too. In fact, rather than pass in the data structure so that now the function has to know what it is, what if I could embed that functionality like searching and sorting and naming into the data structure